Hello friends, and this is Vinay BK. So today's session we'll be going to discuss about we'll be finding the generalized transmission line constants for medium transmission line. Uh, there are three types of medium transmission line as we know. First is end condenser method, and the second one is a nominal T method, and the third one is a nominal pi method. So the constants for nominal T method we are discussing now. So in case of medium transmission line, before going to discuss about a generalized circuit constants, we have to know about analysis of medium transmission line, that is in nominal T method. So I'll just brief about that here. In case of nominal T method of analysis of medium transmission line, the total line capacitance is to be assumed to be lumped or concentrated at center point of line. So as we discussed, the total line capacitance is placed at the central point of the line, half the line resistance whereas half the line resistance and reactance are lumped on either side of the capacitor, that is on either side of the line and on either side of the load, so that the total resistance in case of that, instead of writing R, half will be at the sending end, half will be at receiving end, whereas C is placed exactly center of the parameters, that is exactly will be placed at the central by making halves of the resistance and reactances. So here we know that we'll be getting we'll be comparing the ABCD parameters along with the medium transmission line equation or else the expression. So what we are doing now here, for this particular circuit diagram, we already discussed the analysis of nominal T method. I am just telling how we are getting the expression here. So we'll be getting the one expression is Vs by applying the KVL to the loop 1. So Vs is given by this V1 plus Is into Z by 2. I'll write Is into Z by 2 instead of writing Is into R by 2 plus J into Is into XL by 2. I'll write R by 2 plus J into XL by 2 is nothing but Z by 2. So that what I am writing here, Vs is given by V1 plus Is into Z by 2 is a one expression. Similarly, I can write the V1 by applying KVL to the loop 2. I can get the expression of V1. It's very simple. You can get the expression of V1 as VR plus IR into Z by 2. I'm writing in terms of impedance. VR plus IR into Z by 2. Also you can write VR plus IR into R by 2 plus J into IR into XL by 2. So instead of writing R by 2 plus JXL by 2, I can write Z. So I can write here, instead of that I'll write here it as Z, so that I can get V1 equals to VR plus IR into Z by 2. So these two expressions along with the C here Is. So this Is is given by applying KCL to this node. Is is given by IC plus IR. This is given by IC plus IR, that is we are just applying the what KCL. We can get Is equals to IC plus IR. Similarly, the value of IC, the current flows to the capacitor, is given by V1 into, that is V1 divided by Z we are getting. So instead of writing Z, the shunt admittance, instead of writing the or impedance, I'll represent in terms of impedance or in terms of admittance, so that 1 by Z is nothing but shunt admittance, so that I can write here V1 into Y. So IC is given by V1 into Y. So whereas Y is shunt admittance. So now we'll be go for the expressions. So Vs we are getting by applying KVL to the loop 1, V1 we are getting by applying KVL to the loop 2, Is is getting by applying KCL, IC is writing it as V1 by Z, whereas 1 by Z is nothing but admittance, so that I can write in terms of Y instead of writing Z. So whereas Y is a shunt admittance. So IS expression we know, IS is given by IC plus IR. So for this expression, I'll just substitute the value of IC. IC is V1 into Y. So I'll substitute this V1 into Y into the IC so that I can get IS equals to V1Y plus IR. Okay. So once we are getting V1Y plus IR, I know the value of V1, so that substitute the value of V1, that is V1 is given by VR plus IR into Z by 2. So that VR plus IR into Z by 2 into Y plus IR. Okay, so here look at the expression. Next step is we'll be going to simplifying this expression. How we are writing, multiplying y inside, so that VR into y plus IR into YZ by 2 plus IR. So here IR and IR will be common, so that I can write by taking IR as a common, VR into y plus IR. By taking IR as a common, the left part of the expression is, by taking this IR as a common, 1 plus YZ by 2. Once you are getting this, again I'll rewrite this in terms of ABCD parameter. So IS I can write here as IS is given by Y into VR, instead of writing VR into Y, A into VR, sorry, C into VR plus D into IR, whereas C is nothing but Y, D is nothing but 1 plus YZ by 2 into IR. So by comparing with a standard equation will be get the value of C and D. So coming for once if you are getting IS, next is we have to write, we have to compare with the VS expression of ABCD parameters. So Vs we know, Vs is given by V1 plus Is into Z by 2. Substitute the value of V1 again here is nothing but Vr plus Ir into Z by 2. So that Vr plus Ir into Z by 2 plus Is into Z by 2. So again by simplifying this expression, I'll keeping like this only here, by taking Z by 2 outside, that is a constant. So I'll be substituting the value of Is. So value of Is is nothing but y into Vr plus 1 into y into Vr plus 1 plus Yz by 2 into IR, by substituting that expression to the Is. So next is simplifying. So how we are doing the simplification here? So just look at the Vr. So here we'll be having one Vr, then Vr into Yz by 2. Vr into Yz by 2. Okay, so by taking that Vr as a common, 1 plus Yz by 2 into Vr plus wherever there is IR, take IR as a common. By taking IR as a common, what we are getting? Z by 2 plus Z by 2 plus, okay, Z by 2 plus Z square, look at here, Z square Y divided by 2 into 2 is 4. Okay, by simplifying this we can get Vs equals to 1 plus Yz by 2 into Vr plus Z plus Yz square divided by 4 into IR. This is expression number, you can give this as equation number 1 and this as equation number 2, sorry, 2. So once if we are getting Is and Vs, compare with the ABCD parameter, we can get A equals to D is nothing but 1 plus Yz, okay, 1 plus Yz, A equals to B, D, this is A and this is a D is same, so that it is a symmetrical property is executed. Similarly, C is nothing but here, C is nothing but Y, compare with the expression C is nothing but Y. Similarly, D is nothing but here, sorry, D is B is nothing but Z plus YZ square by 4. Okay, so to so by looking at this expression, we can say it as the network is seen to be symmetrical because A equals to D equals to 1 plus YZ by 2. So if you want to get a network as a reciprocal, substitute the value of A, D, B, C in the expression AD minus BC, we should get 1. If you are getting 1, then the network is reciprocal. By substituting the values of that and by simplifying this expression, we can get the value of AD minus BC as a 1 so that the network is seen to be reciprocal. So this is about nominal T method. Similarly, we will be doing for the nominal pi method. In next session, we'll explain about the nominal pi method. Thank you all.